Today's lesson 9.5, we're going to solve quadratic equations using the quadratic formula. Now, I'll be honest, not a lot of things I remember from middle school, but I do remember this quadratic formula from 8th grade in Mr. Poban's Algebra 1 class. So what we can do is when we have a quadratic formula set up like this, we can solve it by using the quadratic formula. So we can figure out what x is by doing negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's look at that here in example 1. So we've got a, b, and c. Be careful of your negatives. So a equals 12, b equals negative 4, and c equals negative 5. So all we're going to do at this point is plug and chug. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative b, so that's 4 here because that's negative, plus or minus the square root of negative 4 squared minus 4 times 12 times negative 5, all divided by 2 over a, which is 12. So now it's time to do some math. So I have 4 plus or minus 16 plus 240, all divided by 24. So let's do a little bit more. 4 plus or minus the square root of 256, all divided by 24. So x equals 4 plus or minus 16, all divided by 24. So this here is going to give us our final answer. So I have x equals 4 plus 16 divided by 24. X equals 4 minus 16 divided by 24. So x equals 20 over 24, which is 5, 6. X equals negative 12 divided by 24. So x equals negative 1/2. So there you go for example number 1. Go ahead and try 1, 2, 3, 4 all on your own. Hit pause, come back when you're done, and check your work. All right, so for number 1, you should end up with x equals 5. For number 2, you're going to end up with x equals approximately 3 6/10 and approximately negative 5 6/10. For number 3, you're going to end up with x is approximately 1 9/10 and negative 1 2/10. And then for number 4, don't forget you need to set that equal to 0 in standard form. So you have x equals 1/2. All right, so now let's take a look here at example 2. The number y of northern Rocky Mountain wolf breeding pairs X years since 1990 can be modeled by the function y equals 2/10 x squared plus 1 8/10 x minus 3. There were about 77. When were there about 77 breeding pairs? So our y in this case is going to be 77. So I have 77 equals 2/10 x squared plus 1 8/10 x minus 3. Now remember, I need to set that equal to 0. So I'm going to subtract 77 from both sides. So 0 equals 2/10 x plus 18x minus 80. Now I'm going to go ahead and solve this using the quadratic equation. So x equals negative 18 plus or minus the square root of 18 squared minus 4 times 2/10 times negative 80, all divided by 2 times 2/10. Forgot my x squared there. Okay, so now once I do that, I end up with x equals negative 18 plus or minus the square root of 67 and 2400ths, all divided by 4/10. So that leaves me with x equals negative 18 plus or minus 8 and 2/10, all divided by 4/10. So when I go ahead and do the math there, I end up with x equals 16 and x equals negative 25. A negative in this case is not a feasible answer here. So I know that my answer here is x equals 16. Now remember, this is the years since 1990. So my answer here is then 16 years after 1990 in 2006. Nice job. Okay, what we're going to take a look at next is interpreting the discriminant. And the discriminant is just this inside part right here. So this part is our discriminant. Okay, so we can use this to determine the number of solutions a quadratic equation is going to have. So if your discriminant is greater than 0, which means your discriminant is positive, you're going to have two real solutions, meaning you're going to have two x-intercepts. If it is equal to 0, you're going to have one solution and one x-intercept here. And then if this is negative, that means you're not going to have any real solutions because it doesn't cross the x-axis. So let's take a look and see if we can figure out the discriminant here and determine the number of solutions. So if you recall, this is A, B, and C, but I'm only using the discriminant here, which is B squared minus 4AC. So I've got negative 3 squared minus 4 times 2 times negative 1. So I have 9 plus 8, which is 17. This is greater than 0, which means, therefore, the equation has two solutions. Now, let's take a look at this one. Now, if you notice, it's not in standard form, so we're going to have to subtract x from both sides, leaving us with x squared minus x plus 4 equals 0. So again, b squared minus 4ac. So b is, so I've got negative 1 squared minus 4 times 1 times 4. So I have 1 minus 16, which is negative 15. Therefore, since this is less than 0, the equation has no real solutions. All right, you know what to do. It is your turn. Go ahead and hit pause. Try these 3 problems. Come back, check your work. All right, for number 1, the discriminant is 0, so you have one real solution. For number 6, the discriminant is negative 20, so you have no real solutions. And for number 7, the discriminant is 47, so you have 2 real solutions. Now, let's see if we can find the number of x-intercepts. Now, this really is the same as this process here. So the number of solutions is your number of intercepts. So we have A, B, and C. So I need B squared minus 4AC. So I have negative 4 squared minus 4 times 2 times negative 3. So that gives me 16 plus 24, which is 40. So I have 2 X-intercepts. All right, it's your turn. Go ahead and hit pause and tell me the number of X-intercepts of the graph of the function. Taking a look at number 8, discriminant is negative 23, so there are no X-intercepts. For number 9, the discriminant is 1, so there are 2 X-intercepts. And for number 10, the discriminant is 0, there is 1 X-intercept. All right, so to be honest, we have now learned 4 different ways to solve quadratic equations. Some of them lend themselves to, some problems here lend themselves to a better way to solve it, but it's up to you. You can factor, you can graph, you can use square roots, you can complete the square, or use the quadratic formula. Any way you do it is up to you. So here's what I want you to do. I want you to do A, B, and C by any method you would like. It's up to you, your choice. You can do all quadratic, completing the square, anything that will make your life a little bit easier. So when you're done, I'm going to ask you to tell me how you chose to solve these. Go ahead and hit pause and solve your quadratic equations. For number 1, you'd end up with x is approximately 5 3/10 and approximately negative 1 2/10. The best way to probably do A really is the quadratic function or the quadratic formula. Now for B, probably the best way here is using square roots. So you'd end up with x equals 10 and x equals negative 6. Now for 10, you end up with x equals 4/5 and x equals negative 3/2. Lots of different ways to solve this one, so it's really your choice how you would choose to do that. Go ahead and get started on today's homework. Make sure you are following all of the directions.